Okay, well, welcome to the last meeting of the Computational Political Science for Democratization Working Group. We are presenting a paper that we presented at the Midwest meeting, but I don't think any of you were there, so it's new to you. And I don't think we distributed the paper. I think we could do that. So after the meeting, we can distribute the paper. I don't know, then we just take a deal while I'm talking. But anyway, this is kind of an update of the work that the AIM-3D team has been doing. Things have been moving really fast. Valya's been working really hard on running lots and lots of different models and innovating things, and Dmitry's been working hard on cleaning data and gathering things, and I'm just a spokesperson, basically.
Michael has been.
I've been commenting on things. But anyway, I'll talk about what we're doing here. So the main point of this paper is that one of the inspirations for the project was the concluding chapter of a 2022 VDEM book, Why Democracy Develops and Declines, which was an attempt to put like the best performing variants from preceding chapters in the book, the explanations for democracy, and use them, combine them, integrate them into a path model that had some distant variables and some proximate variables and some things in between to try to explain levels and upturns and downturns in democracy. And that was an interesting model. It would suggest that there were causal sequences of variables. And the structure of that model, as you will see in a minute, well, I'll say more about that. So we're trying to develop a kind of AI to see whether it can do a better job of modeling these processes than this path model, which is a special case of the structural equations model, than it could do for explaining these things. And so the data that we're using is what is automatic artifact removal? I don't know what that's about.
That wasn't a substantive variable, but we did it based on the relationships between variables.
Okay.
So the variables,
some things were
let's say all zeros or all ones, they got removed.
Okay. The static variables were removed. They had to be removed. And the democracy data that we're using is data. But there are a lot of other variables that go into it, from World Bank data and other projects. But anyway, what we found is that this AI model does a better job. It's a better model. In some ways, these are encouraging findings because they validate some of the key findings from the path model, which is reassuring. On the other hand, it's a more sensitive way to study this. So this AI model, simple AI model, finds some relationships that were found to be insignificant, statistically insignificant in the path model. And also there were some findings in the path model that I just thought, I don't believe this because this just makes no theoretical sense. And it corrected some of those and gave us estimates that made more sense. So it seems like a better model. And so, and when I finish talking, Dmitry's going to talk about some future work in this. So this is the book, and this is one of the three path models that we had in that book. And the structure of this is always basically the same. The polyarchy, or the electoral democracy index, is off to the right. That is the ultimate endogenous variable here. That's what we were trying to explain in the path model. And I want to highlight in the red box over at the right, there are three variables that this chapter notes as as a protective belt. There are three things that are related to each other. They tend to reinforce each other, and they all have some effects, direct and indirect, on polyarchy as well. And so part of the argument of the chapter is that these things tend to promote homeostasis. They tend to preserve the level of democracy that a country has, whether it's a high level or a low level of democracy. It tends to cement it in place, not cement, but loosely holds it in place. And so if there's some shock that raises the level of democracy, these variables tend to bring it down. In the reverse, if there's a shock that lowers it. But it's not utterly rigid. And then there are other variables that are farther back, farther upstream in the causal chain. I'm sorry, I'm mixing back metaphors there. But at the very end are things that are very causally distant and historically distant, static variables like European population, Protestant population, and resource dependence. And then there's some intermediate variables that are basically modernization variables, literacy, agricultural income, and GDP per capita. And then I forgot to say this is set up so that the solid lines are positive relationships and the dashed lines are negative relationships in the model. And so saying there's this protective belt, instruments homeostasis. Civil society emerges as the strongest direct predictor of democracy for various reasons. Socioeconomic factors indirectly support democracy. And this is kind of a revision from previous literature. This was saying per capita GDP, which everybody had talked about, is the single most important variable for explaining democratization. This, according to this model, has only an indirect effect. Like it has an effect mainly on affecting the civil society participatory environment. And we find a negative effect of agricultural income on just about everything. That is the percentage of the GDP that is owed to agricultural sector of the economy. It's negatively associated with democracy. And other things are in there as well. But anyway, this is the model that was the baseline inspiration for what we're doing here. So the core research questions are, do we get something that's like the same models? We're trying to replicate this model. Do we still find that there are proximate, intermediate, and distal effects that are ordered in that way? And third, can this model address some of the limitations of this structural equation model that has some limited vector autoregression and some other approaches in democratization? And basically the answer is yes. So here's the data we're using. There's the size of the data set. The outcome is electoral democracy. There are the three variables that are in the protective belt: CSO, civil society organization, participatory environment, high state capacity, which is sometimes in this chapter called rule of law. And I think the specific variable is transparent law with predictable enforcement. And then institutionalized political parties. Then the proximate indicators are mostly civil society kinds of activities, anti-system movements, left-wing movements, right-wing movements, violent movements, non-violent movements, etc. But some of those were not included because they were static, like middle sector campaigns, worker farm campaigns. And then very different variables we saw already. And then the intermediate variables, GDP, workers' unemployed, literacy, and also strict presidentialism and majoritarian electoral system, which I didn't put here. But those two things were things that had effects that were counterintuitive to me, and then the AI model they drop out. They don't matter. So I'm kind of relieved that that happened. So this is where things get a little complicated. What we have here is a matrix that shows the lasso regularized estimates of the impact of, let me see. So the target variables are in the columns and the source variables are in the so the target variable of electoral democracy is the first column all the way over to the left. And then the darkness of the blue square next to each one of those variables shows the magnitude of the effect. This is lasso regularized. So it means that these effects are kind of shifted downwards so that fewer of them are considered significant and many of them are set basically to zero. So that induces a simplification of the model to focus on just the variables that matter the most for these kinds of things. So this confirms up there that civil society has the strongest individual effect on electoral democracy, largest coefficient there. And I'm going to get to necessity a little bit later, but I already talked about these other things about the lasso regularization. But anyway, there are many variables that have some effect on other variables. So there are lots of arrows pointing a lot of different ways in this model, but the model reduces the number of arrows that we consider relevant for this. And this matrix doesn't show you the direction of the relationship. The next one does. It's based on another statistic that we're not reporting here. Let's see, I stands for individual conditional effect. Is that right?
Individual conditional expectation.
Yeah, okay, individual conditional expectation, which is a function of how past values of each source variable are non-linearly related to the target variable that they're trying to explain. And this is one of the features of the model, is that these relationships can be nonlinear, they can be nonlinear, but we'll get to that in a little bit more. But this is just the net causal effect, like from the start to the finish of the values of that variable from the extremes. And so there's some interesting things here. The same variables are in this as source and target variables, but now they're color coded so that positive effects are in blue and negative effects are in red, and the size of the effects are reflected in the darkness of these things. And there's a color scale off to the right that shows those values. And so one thing we see are some feedback loops. There are stronger feedback loops in this model than we had in the path analysis before. There was really only one feedback loop in the path diagram that I showed you before, but this one has several feedback loops. And if you look at the upper left corner there, those are electoral democracy and the three variables that are in the protective belt. Many of them have positive effects on each other. So that shows some reinforcement going on there. The big horizontal red outlined row there is for agricultural income, and it has positive effects on very few things and mostly negative effects on most of the other variables that are in the model when it has any effect at all. And then in the black outline bar for economic growth, it shows really deep red negative effects, and those are effects on social movement campaigns. Basically, when the economy grows, there's less social movement activity. People are relatively content and less likely to protest, and so it has a dampening effect on that. So those are some interesting effects there. This is another kind of statistic to evaluate what's going on in the model. These are, so what we looked at before were the magnitudes of the coefficients, kind of traditional ways that we look at regression models, structural equation models, looking at the size of the coefficients and whether it's significant or not. But this is a different statistic, which is forecast necessity. How important is each variable for forecasting the other variables in the last 5 years of the time series? And these are evaluated through a process called edge ablation, which is basically removing the variable from the model and looking at how that affects a loss statistic for the model as a whole. So if removing the variable has a high cost in the forecasting power of the model, then that's a relevant variable that you don't want to remove. But if removing the variable doesn't follow the law for forecasting power, then you can remove it pretty safely. And so that statistic is represented by the green squares. The high forecast necessity is reflected in the green squares. The red squares are ones that are basically set to 0 because they're too small to be very useful for forecasting. There's still a lot of variables that are useful there, so it's a pretty complex model. The scatter plot on the right compares the magnitudes of the causal effects, which are basic Granger causal effects, to the forecast necessity. And so the loss function is on the upper axis, the vertical axis here, and the causal scores are on the x-axis. So the importance, like the causal importance, excuse me, the forecast necessity, I'll put it this way. In the upper left of this graph, you have variables that are necessary for good forecasts, but tend to have rather low causal scores. How can that be? Well, you think about it, if there's like an inverted U-curve or a U-curve for this nonlinear relationship, fitting a linear regression line to that would give you a low coefficient for that. So it would be a low score, but it could be very necessary for forecasting because the shape of the curve would matter a lot for that. In the lower right quadrant of the graph, below the red line, there are variables that have high causal scores, but are not forecast necessary. And that could be the case if if basically most of their forecasting ability comes from variables that cause them. So they're like downstream from variables that matter for these kinds of things. And so this is one of the key findings, is that being forecast necessary is very different from the high kind of Granger causal magnitude. And vice versa. They're not the same things. And so our model basically prefers forecast necessary variables and emphasizes those. Okay, and this is kind of putting things together. It's similar to the path diagram we did before. It's the same model we're talking about. Polyarchy is still over to the right. Then we have the 3 protective variables just to the left of that. And you see a lot of positive and rather strong relationships there. Then there's social movement activities mostly, and national economic growth in the middle of those things. And then the more intermediate variables, literacy, agricultural income, GDP per capita, global economic growth to the left. And then at the very left are the distant, relatively invariant variables that we have forced to be exogenous. That is, we say that none of the other variables cause these things. These are like prime movers behind some of what's going on in the model. So this finds some confirmation for the protective belt, but especially there are feedback loops from polyarchy to elements of the protective belt, and this is relatively new in this model. So not only do these elements of the protective belt influence each other and help stabilize, but polyarchy helps stabilize these things as well. So there's even more interaction going on there that not strictly interaction, but there are more relationships there that help stabilize the model. Agricultural income, which is kind of in the upper left, second from the top. You see mostly red arrows coming from that to anything else. And this model is restricted to just the edges that are forecast necessary. So we removed some things like resource dependence, strict presidentialism, majoritarian electoral system. So kind of to summarize some differences between this model and the Chapter 8 model that had been published before. 3 relationships there between civil society, rule of law, and agricultural income. on the one hand and polyarchy on the other were confirmed, we have found a relationship between an effective party institutionalization and polyarchy that was not significant in the path model, but it's significant now. We can say the same thing about the impact of literacy on polyarchy and log GDP per capita on polyarchy, and these new feedback effects, polyarchy on the rule of law, polyarchy on civil society, polyarchy on literacy. And there's one variable in here that proved to be important that wasn't in the model of upturns in democracy, but we put it in this model, and it was significant. Impact of nonviolent campaigns on democracy is positive. I think I covered everything there. So I'm going to hand this over to Dmitry.
You want to comment on this slide?
I think this summarizes what I've already said. Yeah.
So,
well, except the new findings and future work.
So, actually, we produced some publications in the pipeline. Michael covered this MPSA paper, and we will share it with you. But also, we just submitted several articles to the computer science proceedings, and some of them we just put in archive already. So if you're interested, you can just follow them. And we are very excited that our paper was accepted for ICML conference. That is the top 3 conference in computer science and machine learning.
So, yeah.
So I think that we can stop here and just open the floor to the question to Michael on this presentation.
Okay.